Guys, I'm back with the most exciting stories of all time, Gaussian. So, fast forward. Okay. Maybe before starting our Gaussian. Yeah, okay. We talked about it yesterday. So let me finish this first, and then I will go to the Gaussian. I should do yes. So yesterday we said what happens if everybody takes action that is like each time step t plus 1. I was rushing to what I want to say. At time step t plus 1, each person decides to take the best strategy, best response to the other person's action at time t. Therefore, we saw some cases like this very simple case here that the game may, do you have that? Yeah. That the game may just oscillate and never converge. So I had this idea of, okay, first of all, I'm not curious about this method anymore. It doesn't work even in very simple games. But last night I was thinking, wow, is Hoteling game the only game that I know with continuous action space? Well, the answer is no. For sure, I know quadratic form games, Corno game, Bertrand game, they're all quadratic and continuous space. And I was saying, okay, I don't want to study that. I want to study Corno behavior. It's similar to what happened. It's similar to Hoteling problem, but we have another continuous space, and it is the space of distribution over action space, which is mixed strategy games. And for example, this simple game of Alice and Bob, what if we let players use mixed strategies and have a, like here, right? So instead of saying that's what actually Nash did and proved that for any finite space we can find a Nash equilibrium, mixed strategy Nash equilibrium, right? Is it finite or compact? I don't know. Therefore, I am saying, so what is the action space here, 0 and 1? What if we say Alice action space is now choosing a strategy over a distribution on 0 and 1 is a strategy. So it will be something like P and 1 minus, okay, we say A and 1 minus A for Alice, where A is between 0 and 1, and B and 1 minus B. With probability A, Alice chooses 0, and with probability B, Bob chooses 0. Right? Now, what are the Nash equilibriums of the game? First of all, I think anything works. if Alice chooses, okay, what is the definition of Nash? Expected of utility of UA of um, so this is Nash. Nash is let the players be independent of each other, Alice, and so Alice action is a Bernoulli random variable, right? UA of, I call it A. Maybe I should not choose A and B. Okay, we change them to P and Q. And Alice action will be A, which is 0 with probability P, and 1 minus P, it will be 1. And B, Bob will be 0 with probability Q, 1 minus Q, it will be 1, right? And Alice's best strategy is star B star. So Nash is independent, each player choosing their own distribution, right? Greater than expected of UA, A, any other A and B star, right? So what is UA, by the way? And they are independent. P and Q, A and B are independent. So UA will be 1, A equal B, right? So what are the odds I and B are equal? Either both of them are choosing 0, which is probability PQ, or both of them are choosing 1, probability 1 minus B, 1 minus Q. And we choose a star here, the best strategy, greater than P, Q star, plus 1 minus P, Q star, right? And actually P star is argmax of this thing. So if we do differentiate, this is a linear function, so it is P 2Q star minus 1 plus 1 minus Q star. So if Q star is greater than 1/2, P should be 1. If Q star is less than 1/2, P should be 0, P star. And if Q star is 1/2, P star can be anything, no constraint, right? Now the best response is to be best response because the game is symmetric. If P star is 1, similarly we can find the only option for Q star is 1, which is one of the pure Nash equilibriums. Both of them choose 0 and 0 as the Nash equilibrium. If P star is 0, Q star is 0, right? And so we have another Nash equilibrium, 1 and 1, right? And pure Nash. And then when Q star is 1/2, we have no constraint on P star, but the same thing should apply for P star. And when we flip the role of P star and Q star, so the only Nash equilibrium is P star equals Q star is 1/2, which is with probability 1/2 they take action 0, and with probability 1/2 they take action um, 1 minus 0. Sorry, yeah, 1. Okay, I'm thinking. Perfect. So it is a 1/2 0 0 plus 1/2 1 1. It's actually interesting that which one will be the convergent one. Well, if you're at 0 0, it will be convergent. Okay, now, okay. The difference is previously when the action space was, strategy space was discrete, we could only switch from 0 to 1 and it caused the problem to oscillate. Now our action space is actually different, so we are in a convex space, right? We are on convex space of delta of 0 and 1 for each of them. SA and SB are in this space. So we can use a convex perturbation. How did we do convex perturbation? So if we are in a convex space, we can be this and we can choose any other point and do a convex combination. Right, so it is, we have P star, now what the deviation looks like. So if you look at it through a dynamic lens, let's say SA of t was Pn 1 minus P for Alice, and SP of t was Q and 1 minus Q. What will be SA t plus 1? Well, if Q is 0, Q is 0, then P will be 0 and PT plus 1 will be QT. If QT is 0, PT plus 1 will be 0 and 1. QT is 1. PT plus 1 will be 1, which will lead to action 1 and 0. And if QT is something in between 0 and 1, right, what will be the best action? We computed here. Best action, or actually, if QT is anything greater than 1/2, PT will be 1. So QT less than 1/2, PT plus 1 will be 0. QT plus 1 greater than 1/2, PT plus 1 will be 1. QT plus 1 equals 1/2. It shows that actually 1/2 and 1/2 is not a stable strategy, but the two pure Nash are more stable. PT plus 1 will be 1/2. So what is SPT plus 1? Similar, right? PT, sorry. they are qt not qt plus 1. Pt greater than 1/2 qt plus 1 will be 1. Pt is 1/2 pt qt plus 1 will be 1/2, right? Now let's assume we are at one of these points, right? This is P and Q. This is actually a three-dimensional object if you look at it, right? So it should be like like P, Q, and T, right? So if I start, and this is 1, this is 1, and if I start at 1/2 and 1/2, we will stay on this line, right, like this. If I start we can also, even here we can interesting, even here we can oscillate. So if I start in this lower square, then both of them are less than 1/2. Oh shit, this is so funny. If I start there, both of them are less than 1/2, I right away jump into Nash equilibrium of 0 and 0. So the whole area here, will end up on 0 and 0 right away at t plus 1 and stays there. So it shows actually 0 and 0 is a stable in our definition, because if I move it around here, it comes back to this 1 and 1 right away. It's stable up to like 1/2, right? So anywhere here it comes here, and it shows that 1/2 and 1/2 is not a stable one, because I just need to move a bit towards this lower square so that it goes all the way to 0 and 0, just in one step of the time after. And what if I'm in this upper left square? Let's use another color. Very interesting. So if I'm here, you can see it? Yeah. All of them will jump right away to 1 and 1. Very interesting. I love this. That was such an interesting problem. I will jump right away to 1 and 1. And if I am in either the two off diagonal squares, we won't keep up. Okay, by the way, the yellow one, similar to the purple one, is a stable one. If I am in either one of those, will I oscillate, or what's gonna happen? Even we need to define what's going to happen with the ones on the border of 1/2 and the other part. So let's go choose color green. Let's assume P is less than 1/2. Q is greater than 1/2. So at time t plus 1, which is time 1, where will I end up? P is less than 1/2. So Q will be 0. Q will be 0 here on this page, xy or xz, and Q is greater than 1/2, so P will be 1. So it will end up here. And now we will get back to our story of, oh, okay, just oscillate between 0 and 1. So time 2, we will be here. Don't you like this? Time 2 will be P0, Q1. P0 here, yes, Q1. So we are oscillating from here to here. Then we will become here again. Then we will go here. So this is from here to here. Then here, then here, then here. The other part, let's go another color, maybe blue, light blue, or deep blue, okay? The other one is for this part, which will have a similar effect. They've just filled these empty spots here, but they keep oscillating. By the way, all of the points. If you are anywhere greater than 1/2 on P and less than 1/2 on Q, all of the blue square ends up going on this path. And you can see that, first of all, they are not converging at all, which means, they won't, the P and Q just keep oscillating for them. They won't converge. They won't converge, so it doesn't make any sense to define a sense of stability. The only ones are 0 and 0 and 1 and 1, and the square related to them. Now let's check one of these edges. Let's go. We have green, yellow. We have yellow. I don't know. Okay, orange. Orange may be another color. So orange, we are on this line here, which P is 1/2 and Q0 is less than 1/2, right? And where will we end up? Q1, Q1 will be, P1. P1 will be 0 and Q1 will be 1/2. So we will end up P1 0 here and Q1 1/2. We will end up here. All this line, all this interval goes to this point here. Then P2, now it starts oscillating probably, will be 1/2 and Q2 will be 0, which is Q2 0 and P2 1/2, which is here. Yes, very interesting. So then we keep oscillating between these points. They don't converge too, and they are not, okay, it doesn't even make sense to define stability for them. So you can see, for the simplest game ever, we cannot find a good notion of stability. But if you would say which one of these three Nash equilibriums are more interesting, I would say the two pure ones are more interesting because they're kind of stable. Like even if you can deviate in any direction, both P and Q, and they will come back there. So Nash, the players are independent, and then we have base correlated Nash equilibrium, which kind of, it's like having a mediator giving action recommendation. That's what it is. That is even weaker than Nash. Perfect. I'm happy now. In general, I don't know, like what happens? The game theory is supposed to help to predict what happens in real life. But even now, even like on a theoretical level, we don't have a satisfying definition of equilibrium, or you can say, well, it is saying what's going to happen. There is no certainty. We are just jumping around. That is life. Life is that. We don't have solution all the time. We don't find the best solution altogether all the time. So if you fucked up and like it was a teamwork, like this is a teamwork, right? This game is a teamwork. And you try to make it better, but it still doesn't work. Sometimes it's not about you. Both people, 3 people, 4 people, all the team people are good. They wanna coordinate, but the situation of the game is bad. Life lessons. All right. So it's not always about us. Don't judge each other's intent and assume that everybody is doing the best. Maybe that's that button, dude. I need to be. Wow, this is so cold. I need to be a teacher or something. Morality with game theory and convergence of Nash equilibriums. Stability of life. Make your life stable by finding a stable equilibrium. Wow, that's good. That's good. Alright, let's get back to Gaussian. It took only 25 minutes of our life, which is amazing. I'm happy that I spent just 25 minutes and learned so much, used different colors. I loved it when it oscillated. It was very nice. So now I want to say, let's go Gaussian. What? For Gaussian, what do we want to do? We want to add 3 plots for when mu is 100, something like that. And okay. I was reading the book Game Theory, and it was saying like, okay, if this is the situation, everybody is doing their best to coordinate, and because of the nature of the game, you just cannot converge to any equilibrium, well, guess what? You better change the game. Add more elements, right? Because they are a model of the game, but we can add a third option. You can add a third option, and that's it. And hopefully there you can find an equilibrium that is quite, yeah. Because at the end of the day, game theory and the whole theory is just a model of the life. You can come with any event that is any phenomenon. If you have a model of it, you should be able to come up with another model too. Dude, I am on my armchair theories mode of best mode of all time. Really, if you are a fucking armchair theorist, a mental masturbator, you should be able to look at a phenomenon and at least come up with 2 models, 3 models, make it big, make it as big as life, 1,000 models. You need to be able to look at the phenomenon from different angles. So maybe that's a good idea for us to start modeling the eBay problem from different points of view. One became from this, oh okay, consumers come and they look at the lists and they are looking for their own category of products. And why do we have only one story? Like the same thing, yeah, they have one category of products, but the mathematical models, why should it be the same all the time? Is there any other way that we can model the same story with mathematics? That's a great question. Wow, I spit a lot. These were perfect. I have to delete them now. Yeah, you have a lot of achievements in your life, guys, but you must be willing to let them go as well. We talked about Nash equilibrium. We made a great memory here. Now it's the time to move on and explore other horizons. Bro, I am killing it today. What's going on? Honestly, I'm just talking for myself. I need to find exactly this part of the video and just make all of my shorts from this part. Okay, now I'm just got self-conscious, I cannot follow up. But it is it! Life is this! Fuck yeah! Okay, let me delete this stuff because they are in my thesis notes. So, wait a second. I was deleting. Okay, this is Alex and Bob. Let's delete this. That is nice, actually. So let me add this here. Can we come up with another story, another model, not another model for the same story? Maybe use topology this time. Maybe use, I don't know, maybe use something else, algebra instead of probability. I'm so happy. I feel mentally satisfied. Orgasm, whatever. Now let's go back to our Gaussian and check. Okay, what's that? So Thibault did us a favor. He checked our formula for sigma AI AJ. He said that probably has a mistake in calculation. I'm gonna check that, and then yeah, we are going to do 3 more data parameters for mu100, and then we will send the plots to Al. That's enough. Maybe we think about plotting the level curves next, but that's it. So let me write it here. 1 AJ. Dude, I wrote down sigma AJ but typed it like latex. This is so funny. Let me show you. Oh, you don't have it. I wrote down sigma AIJ instead of writing sigma AIAJ. Human beings are so funny. Then first sigma AIJ, 2 plots for mu100, 3, and then we will send them to Al. 3 will be level sets for AI. That's it. Then we will think about it further. Perfect. I have some other options too, but this is the current agenda. Let's see what people says. So Thibault says second summon, you have it. You have a factor 2 minus n minus 2 times r in the numerator. Is it numerator or nominator? Numerator? Yes, numerator. Oh, it is numerator and denominator. 2 different words. I thought it's just nominator and denominator. So numerator means, what does it mean? Somebody that numerates? I was numerator, denominator. It is no, I was nominator, denominator. So numerate means counting. Numerate. Having a good basic knowledge of arithmetic, able to understand and work with numbers. Oh. Literate and numerate. Okay. Numerate. Is it numerator? Oh my god. Numerator. Bro. Numerator, signal. It's at least it looks better than signal. Fuck you, VGS. Numerator. Once you don't use these words. Numerator and numerate. So what is it? Is denominator. What is denominated? We have denominated, but we don't have denominate. Meaning, denominate means of sum of money expressed in a specific monetary unit. The borrowings were denominated in US dollars. Oh. Denominate. Call, name. The whole train was denominated bullshit. Bull outfit. So denominated. So it makes sense, right? No, okay, it doesn't make sense because numerator is somebody who, and numerates is somebody who is like able to do math. Numerator is denominates means like the unit, using the unit. Alright, if you confirm this is indeed mistake, this might be the final explanation of why we're getting it. What do you think? Alright, let's check this. Oh, okay, it says you have 2 minus should change to numerator, but I think it should be 1 minus n minus 2r. Dude, am I showing both you? Okay, no, okay, perfect. Let's go check. Okay, I computed this 1,000 fucking times, but I will do it again. That's it. I mean, you witnessed how many fucking times? How many fucking times I computed it? And I want to mention, so we have coordination by selling information. We want to open our Anaconda. Let's check even if we have it, it is just something in the code or is in our computation. Shit. Okay, no. So in my computations here, so in my computation, my final computations here, what I have here is 1 minus n minus 2r, but at the end line here we have 2 minus n minus 2r. So, fuck. So it seems if it is something, it is just code and my computations match. Any problem, it should be with my computations. Desktop, Python, research, Gaussian. This is it. Second summons. It is Nash, complete information Nash. Where is it? Sigma AI AJ is S squared var omega over 1 minus n minus 1 r second plus r. Where is r coming from? So we have 2 minus n minus 2. Where is 2 minus? Oh, okay. I'm not looking at the formula. 2r times 2 minus n minus 2 times r times t squared. Yeah. I don't want to look at my previous calculations because probably just directs me to the wrong direction. I haven't looked at them for a long time, so I probably better start recalculating them from zero. My brain is fresh. T squared sigma theta I squared over 1 plus r squared 1 minus n minus 1 r. Okay, so that's the problem. Now let's look at our formula for complete information mesh. AI. We can assume they are centered. AI. Let's also write it in a nice way so we can share it with people if we want. AI is S omega plus T theta I over 1 minus n minus 1 r plus r t j not equal I theta j minus theta I, right? One plus r times 1 minus n minus 1 r, perfect, which I want to make it different this time, s over 1 minus n minus 1 r s omega plus, what is the theta i's? 1 plus r 1 minus n minus 1 r, we have 1 plus rt plus, then the rest of them are n minus 1, which is minus n minus 1 r t theta I plus j not equal to I theta j, sorry, rt theta j, actually that's better, rt 1 plus r over 1 minus n minus 1 r, right? That's actually a really good idea. Let me check. Perfect. So RT sigma, oh, you're not seeing it, okay, it doesn't matter. J I theta J, right? That's what we have. So it's S omega T theta I 1 minus n minus 1 R, RT j not equal I, theta j minus theta I, 1 plus r, 1 minus n minus 1 r. Now I wanna just make it look better. That's better now. And then it ends up being s omega over 1 minus n minus 1 r plus what is the numerator for theta I, and the denominator will be 1 plus r, 1 minus n minus 1 r. So 1 plus r times t minus rt times n minus 1. Perfect. And plus rt over 1 plus r theta j. Everybody agrees. Which will be s omega 1 minus n minus 1 r plus so we have t times, so we have rt minus n minus 1 rt. So rt 1 minus n minus 1, 1 minus n minus 1, what will be 1 minus n minus 1 is 2 minus n equals minus n minus 2, right? Minus 1 minus n minus 2 r over 1 plus r 1 minus n minus 1 r theta I plus the same shit for theta j. Perfect. And now AIAJ, sigma mu AI, mu, set mu 0, center, mu 0, and then AIAJ sigma AIAJ is expected of AIAJ then AIAJ let's write down AJ2. Copy. AJ equals J, and we can call this one let me change it to this. I want to separate the J from the rest of the sigma elements. right? And then I want to say k that is not j nor I. K not I and j. It's okay. Perfect. This will be, sorry, this will be I, not j. I. And AI will be, maybe at this moment I need to change the view. I'm here and I'm looking at the, that's what you like to see. AI is this. AI, now I have to change this to I and have to change the other one to J. And the rest is the same. Now AIAJ J equals, what are they? We only look for omega squared, theta j squared, theta I squared, and theta k squared. The other elements are 0. Right? So omega squared will be s squared over 1 minus n minus 1 r squared, omega squared, plus, what is theta I? Right? Theta I squared is RT over RT squared. So we have RT from AJ, and we have T 1 minus n minus 2 R, right, over, no, this is not nice, RT times T1 minus n minus 2 R over 1 plus R squared 1 minus n minus 1 R squared. Fuck off, I am focusing. 1 plus R squared, 1 minus 1 n minus 1 R squared. This is theta I squared plus theta j squared, similar thing, T 1 minus n minus 2 R times RT over 1 plus R squared 1 minus n minus 1 R squared theta j squared plus sigma for k's, right? For k, you can say sigma k not equal to plus sure, RT over 1 plus R 1 minus n minus 1 R squared, R squared, T squared, 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 K, not I and J, theta K squared, plus some elements, sigma like this, theta LK, plus some elements, theta L omega, right? Then expected of AI AJ. This is like orange, and this is like this is it. Expected of AJ will be S omega S squared over sigma omega squared over 1 minus n minus 1 r squared plus, well, these two elements have the same shade, 2 1 plus r squared 1 minus n minus denominator r squared r t squared 1 minus n minus 2 r that's it, no squared, sigma theta I squared plus r squared t squared n minus 2 over 1 plus r squared 1 minus n minus 1 r squared sigma theta I squared, which will be S squared sigma omega squared over 1 minus n minus 1 r squared plus we have t squared in common, 1 plus r squared 1 minus n minus 1 r squared, then we have t squared, we have rt squared in common, so we have 2 minus 2 n minus 2 r plus n minus 2r, rt squared n minus 2r. 2. Also, let me add some zeros here. 0, plus 0. So RT squared is in common 2 minus 2n minus 2r plus n minus 2r. Sigma theta I squared, which will lead to s squared sigma omega squared 1 minus n minus 1 r squared plus rt squared. So we have 2 minus n minus 2r. I think my computation lead to the same thing, different from Thibault. R over 1 plus r squared 1 minus n minus 1 r squared sigma theta I squared. So Thibault said this is what you have, yeah, what I have, which is 2 minus n minus 2r, right? What did Thibault say? Thibault says make it 1 minus n minus. I don't think so. And I had 2 minus n minus 2r previously. Okay, let me share it with him. So sorry, come here. So these ones, can I have a select option? Direct, add page, copy, cut, delete, erase, save as a file. Not edit. Okay, edit. Choose them, and now I can more. Save as a file, PDF file. Where am I saving them? What is the name? Ringtone, pictures, alarm. Here, just what is this done? Name, Sigma AI HA. Now if I can, where is it saved? Share it. Do you have it? I don't want you to have it. PDF files, recent files, Sigma IAJ, perfect. Now I'm sharing, send the copy. I don't know, my computations say something else. La 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 la, rain is coming. check if it looks good. It looks pretty good. So thanks for checking the code. However, I could not find your formula with my calculations. And I end up with the same thing. Two minus and minus 2 are factor I attach my calculation yes. So what was the next step? Plotting for mu100. and sending them back. Damn. Really, it was nice the talk we had on the stability of the Nash equilibrium. What if they consider, I think it will be those games. Yeah. That's exactly it. Yeah, so for the game we studied, we only assumed that we only let one level of hierarchy of beliefs, that I will, in the next time step, I will take action based on the other person's action in the previous time step, current time step. If we let two levels of hierarchy of beliefs, what would happen? That's actually, I'm curious to know. The thing, I think it will be fine now, but we can have rock, paper, scissors that even two level of hierarchy of beliefs won't help. Anyways. Well, if we let unlimited levels of hierarchy of belief, which is actually the thing that makes game theory distant from real life, right? I will tell you why. Because the game is called 2/3 of the average, and this game what is this game? We have a population. Everybody has to choose a number from 0 to 10, right? Maybe even continuous. So let me explain it to you. All right, let's go over. So it's all about hierarchy of beliefs. How do you write hierarchy? Maybe just game theory is not a good tool for studying this and makes it complicated, and we have to come with another theory like behavioral econ. So how do I write hierarchy? Oh shit, 28 minutes ago. Oh my god. Fuck, I lost the final. Maybe it's still on. Let me just pause you. So, got back. I missed the final. We got a gold medal. We got a gold medal. Dude, when I'm in my thinking mode, I cannot talk. Okay. We got a gold medal. That's it. That's me. All right, let's get back in 50 or 15 minutes. Yeah, let's finish it in 50 minutes because there's another final. What is this? Square. Oh, open face up. Hierarchy. Okay, let's go hierarchy of beliefs. Is it the way to write hierarchy? Hierarchy. Actually, well, the last one was Y, which is obvious, but I read it right. So what if we let 2 levels of hierarchy of beliefs? 2 levels. Last time we were just doing best response to their action, right? What if we let 2 levels of hierarchy of beliefs? So this means that our people are more understanding, right? Because they put themselves on the other person's place, and then they say, what would I do if I was him? So if AT is 0, BT is 1, if it is 0, 0, so let's go. AT is 0, BT is 1, and we are, it's A, it's B, we are here. What am I showing you? Yeah. If you are here, so AT plus 1, Alice at time t plus 1 says, previously she used to say BT is 1, so I better take action 1. Now she says BT is 1, and he saw me taking action. Fuck, that is that has a loop in it, right? Okay, if you want to say hierarchy, we will say Alice AT plus 1 is argmax of on A of UA of A and B star, which B star will be argmax on B of UB of A and B. So AT and BT, right? So B star, so Alice doesn't say I will take the best action compared to BT, which is 1. Alice says I will take the action that is the best once, by this assumption that Bob is taking the best action for her AT. So this one, AT is 0, so B star will be 0, then this will be 0, and what will be AT plus 1? AT plus 1 will be 0. So here we will go to AT plus 1, which is 0, right? Let's see if BT plus 1, what will BT plus 1? BT plus 1 will be, I think it will keep oscillate. It won't oscillate, but we will keep staying the same place. Oh my god, this is so fucked up. Like, this life is fucked up. This life is a shit. This life is designed bad. No guys, don't listen to these bullshits. Have a positive mindset. Okay, so BT plus 1, if you want to do the same, we should say argmax on B, UB of Oh, maybe the reason is that they are selfish and their utilities are just, well, okay, that is not true. This case is not them being selfish. In a sense it is, but this game is a pure game of coordination. Both of them enjoy matching their actions with each other. So both of them will like to end up being in the same place. But because they are maximizing their own utility, what if we make them irrational and let them choose the other person's utility? Okay, so BT plus 1 will be UB of A star and BT, and B, where A star is argmax on A of UA. So you are actually, this is not being an asshole. This is saying, okay, I let the other person be the asshole he wants to be and be selfish. I assume that and I take action. So maybe the lesson we learn is that you cannot just hang out with selfish people. Even you try your best, they end up ruining the game. You are also selfish too. So at least for games of coordination. Anyways, on A and BT. So BT is 1. A star will be 1. BT will be 1. So they keep staying at 1 and 1 forever. Previously they used to oscillate. Now they stay in the same place. But if we let them have infinite amount of hierarchy, what happens if we let them have T levels of hierarchy, right? So let's T levels of hierarchy. Of beliefs. So what does that mean? First level means I want to write H level. H stands for hierarchy instead of T, which stands for time. So what is it? We have an action set AT and BT equals what is it? 0 and 1? Yes. 0 and 1. Then let's say A H in 1, 2. Well, mathematicians for sure came up with a model for hierarchy of belief, but I'm not gonna. So AH, if is like H order level of hierarchy of belief, should be argmax on A UA of A and BH minus 1, right? That's it. That is so simple. Yeah. What is your H order hierarchy of belief says just optimize for him doing his, for the other guy doing his H minus 1 order of belief. Let's put the H on the top because T is for the subscript. H minus 1, and while we know that A0 is 0 is AT actually, and B0, which is kind of T plus 1, T plus 1 is 1, which is BT, and then we also have AT plus 1 will be AH, and BT plus 1 will be BH. Right? So this is actually, for this game, this is an easy computation. UA of BH plus 1, you always have to match. So AH will be BH minus 1, right? So we have AH is BH minus 1, which is H minus 2, right? This is the sequence, and AH minus 1 will be BH minus 2, and the same way goes. We know that A0 is 0, B0 is 1. We know that A1 is B0, which is 1, when we know that B1 is A0 is 0. Therefore, it just, they are oscillating in a sense again. So hierarchy of belief, in a sense, letting them having H level of hierarchy of belief is similar to letting them, wow, this is so interesting. Did you see what happened? Dude, this was so interesting. So letting them having H level of hierarchy of belief is equal to letting them play just one order hierarchy of belief. Each time step they are playing best response to the other person's best response. Alright? But just we pick the ones at H, like at each H interval we look at them. We ignore the ones in the middle. So it is suggesting us that none of them will converge actually to the Nash equilibrium. So it will be the same thing. So actually this is the formula. A T plus 1 will be A T plus H, but this A, I want to put a hat on it, which is, this is from previous study. And here we can find out that if H is odd, we will oscillate, and if H is even, we stay the same position, which both of them are not good, by the way. Either you stay at the your same position, you are both are receiving 0, or if you change to the from 0 1 to 1 0, you will both end up having utility 0. None of them will lead you to the Nash equilibrium, which is good for both of you, which is 0, 0 or 1, 1, which you will have, and you will end up having utility 1. Now, what does Nash equilibrium says? Nash equilibrium says that I'm gonna let you have infinite amount of utility of beliefs. Oh, by the way, I wanna connect you to the armchair theory video and game of 2/3, right? So what will happen if I let h go to infinity? Cannot be, you know what it reminds me of? We cannot do let h to infinity. H infinity is quite different than taking a limit of what was that? We had something in probability theory, infinitely often. Yes. Reminds me of something like that. If it happens infinitely often, what was it? Kolmogorov theorem? What was it? Anyways, I don't remember it now. It will finally hit the comes back, right? Measure theory gives me the same vibe. For each finite amount, we will end up 0. How is the hierarchy of belief in game theory? Okay. So you can see that this game fucks you up if you have limited hierarchy of beliefs. But oh, okay, that's why I watched the armchair theory video. That's a very nice video. Let me. Wait a second, why is it here? One of the main reasons I started like trying to come up with more practical studies, armchair theory. Armchair historian? Wow. So many armchair things. Who are these? Armchair Egyptology. Oh, this is the one. The failure of armchair theorists.
The problem of the armchair theorist is not unique to economics. Cozy armchairs can be found across a wide range of fields. In fact, it's likely that each of us has taken on the role of the armchair theorist from times of migrants from states like why highways get built where they're built.
So okay, this is a video that you can watch, the failure of armchair theories. Let's look at the channel. These are interesting. How to think about the story of rationality. These are good videos on econ, I guess, right? Dollar auction game. suddenly exploring Oslo. Okay, so the guy is just putting some videos from his like everyday life and biking the trip, bike packing trip, and some of also his thoughts, decision making, and this kind of. Actually, I like to watch these videos to confirm my own current beliefs. All right. So we have this game of 2/3 in that video. You can see that it shows that people in real life usually do not have this infinite amount of hierarchy of belief. And once you have the infinite amount of hierarchy of belief, yes, you may end up in Nash equilibrium if the game has a Nash equilibrium or something. But in everyday life, so the game is that, okay, we have a lot of people, the winner, and we ask everybody to report a number from 0 to 10, and let's assume the continuous space, and whoever is closest to the 2/3 of the average number of the people, like everybody, we sum them and then divide. 2/3 of the average wins the game. All right. So somebody may say, okay, people are choosing randomly between 0 and 10, then the average will be 5, so I should choose 2/3 of the 5, which is 6, right? 6.6. This is one level hierarchy of belief. Actually 0 level. This is like maximizing your action with respect to 0 state, like we did in our first study. Then one may say, what if everybody does that? What if we let everybody has one level hierarchy of belief? So everybody wants to say, everybody thinks people choose the best answer. Best answer will be 6.6. Now 2/3 of 6.6 is like 2/3 of 6. What is it? What will be the 2/3 of 6? Let's do it one sec. Okay, everybody says 5/3. Then, if I'm a bit smarter, everybody says 5/3. I rather say 5/9, because average of everybody will be 5/3, and I will say and if we are asking a big community, the whole society is big enough. By me saying 5/9, I'm closer to the 1/3 of the average. And then if you let everybody has this knowledge and like computation power, everybody says, well, let's say 5/27. And then it goes 5/3 to the power of n, which means if you let people have higher level of hierarchy of beliefs, we will end up to 0. But they do it in the real life too. They do the same game in the real life, and you can see that the results has some peaks at 5/5, 5/3, 5/9, and then so it shows that people have different levels of, and actually not a lot of people are saying 0. How is 2/3 of average, by the way? 2/5 over, that should also go to 0. Yeah, 10/3 will be, 10/3 will be 3.3. So even 2/3 of the average goes to 0. Anyways, but nobody says 0, unless he's a game theorist or something. So that's what makes our models in game theory unnatural, because we assume people all of them are rational players. No, that's not true. That's actually interesting to check how people in chess play. Anyways, so okay, I don't know how to make it. If now people have infinite hierarchy of beliefs, how can we end up with Nash equilibrium? If I have infinite hierarchy of belief as Alice, if I take action 0, Bob wants to take action 0. Not really. Here we have 2 Nash equilibriums. That's one other thing about this game is that it has 2 Nash equilibriums, and it fucks it up. And it's not just only. Actually, this is also interesting. Now let's look at the rock, paper, scissors. If we do it for rock, paper, scissors, will we end up oscillating among the 3 points? So rock, paper, scissors says rock, paper, scissors. Yes. So rock, rock 0 0, rock, paper 0 1, rock, scissors 1 0, paper, rock 1 0, paper 0 0, paper, scissors 0 1, scissor, rock 0 1, scissor, paper. What if you have multiplayers? Oh shit. That's actually the thing. Okay, so multiplayers. Welfare. Right, okay. These are the other 2 topics I want to mention. Say scissors, paper will be 1 0, and scissors will be 0 0. So this game, actually this game has no Nash equilibrium, right? Yeah, this game doesn't have any pure Nash equilibrium. It has a mixed strategy Nash equilibrium, which is 1/3 paper, 1/3 rock, 1/3 scissors. You play with these probabilities. So if you say RPS, actually, I'd rather say theta 1, theta 2, 1 minus theta 1, theta 2. You can see that theta 1 equals theta 2 equals 1/3 is the answer. Is the unique mixed strategy Nash. So what happens? What happens if we let one level of hierarchy of beliefs? So we are 0 0, or we are 0 0. We end up. You are playing rock. If I wanna get better, I will end up going to paper. You will also end up paper. If I'm playing paper, last round you say, okay, this time I'm going scissors, I will go scissors. So we will end up rotating in this actually we need to on this diagonal. If I am playing rock paper and you won, next time I'm saying I'm gonna play scissor, but you say you're playing rock, I'm gonna keep it paper. So we will end up scissor paper, right? And if I'm gonna which ends up me being winning, if I'm playing scissor, you will want to play rock next time, and if you are playing paper, I rather play scissor again. So we'll end up scissor rock, which will be here, and from scissor rock we will end up, I guess, to rock rock paper again. So if I'm playing, you are playing rock, I will play paper. Oh, we are playing paper. I'm playing paper, and if I'm playing scissor, you want to keep playing rock, so you will come here and so this is one like a Markov chain thing. Was it that? Is that how we proved that? Yeah, I think we used Markov chain to prove Nash equilibrium is unique, and like the contraction theorem, not the Brouwer's. Okay, so we go to paper scissor, paper rock. If I'm playing paper, you wanna play scissor. Okay, it just keeps going. If I'm playing paper, you wanna play scissor. If you are playing rock, I wanna keep playing rock, paper. So we will jump here, and from here, if you are playing scissor, I wanna play rock. If I'm playing paper, you wanna play scissor. So I will come here. And if I'm playing rock, you wanna play paper, and if you are playing scissor, I wanna play. If you're playing scissors, I wanna keep playing rock, so I will come back here. So it's another loop. Yeah, and these two loops, you can see that they have nothing in common. Because if once they end up having something in common, it means that the rest of the path should be the same. I think these are the parts that makes it algebraic topology or something. Well, at least for the discrete space. And then we oscillate, we keep oscillating. Yeah, these are similar ideas like a Markov chain. So my intuition is that in each discrete game, we will end up discrete or finite space discrete game. Maybe for like a countable but infinite space of actions, we have a more complicated situation. Yeah, we definitely have. So for finite and discrete, which means finite requires discrete, we can probably partition these action tuples or pairs to action pairs or tuples to we can partition this action space and they will make a loop or something, or they are probably end of a leaf and then they join a loop, or if they are Nash equilibrium, they are the loop itself, right? Damn, it is very interesting to study this dynamics. Well, Nash did a great job. So Nash is somewhere you want to stay there. By the way, I am letting people to both deviate. Okay. Once you let both of them deviate, well, if you are, yes, because in definition of Nash, we just let one of them deviate. Now we are letting both of them deviate. Interesting. I think the same thing will apply for multiple players. I mean, for multiple players, actually, it's more confusing. Let's assume we have like 3 players, and if they want to match their actions, I mean, even the problem is not well defined. I mean, we can do something about it. Right? It's not a big trouble. So let's say we have Ali ABC, who is named with C, Charles. So Alice, Bob, and Chris, and they have action. Their action is 0 and 1, and utility of them is just matching, is 1 A equal B equal C. So it's either all 3 are 1 or all 3 are 0. So let's assume AT is 0, BT is 1, and CT is 0. Now CT plus 1, where should he go? Right? If AT and BT are the same, he can go both 0 and 1. He has no preference. Let's say he goes 0 because he's 0. And if anybody goes then BT goes 0 for sure. So it's a game of like, we want to go something. It's like kind of voting, because already 2/3 of us said 0. BT says, all right, I will go 0. Actually, yeah, BT will go 0 for sure. But if CT wants to go for the minority, I mean, they may not. 0, 0, 0 is a for sure. So it's like a leaf. So all the situation when we have 2/3 of the population, one thing they may end up But this is an extra assumption I'm adding to the problem. So yeah, we can have these leaves too that end up in. This is actually a case that the space goes to either one of their Nash equilibriums and stays there. Once you get into Nash, you will stay there. Perfect, beautiful. But sometimes in some games you may end up staying in rotations, which is not gonna converge. Multiplayer's welfare. What about welfare? So in these games of matching are actually games of welfare. What are you talking about? Yeah. Games of matching, your utility equals the other person's utility. Not really. Is it true? Yes, your utility equals the other person's utility. So yeah, even in the case that everybody tries to coordinate, so welfare will be the same. Very funny. So even all of you wanna help each other, the nature of the game may stop you. What if you have competition, like then you probably can't compete as much as you want. Yeah. All right. Yeah, if you are in a zero-sum game. Perfect. I think I got some intuition. That was a nice time. What is this, guys? Why are you so obsessed about steroids? All of my friends are saying, go get a steroid, bro. Or don't get it. I don't get it. Okay, I'm getting tired now. I know I have to do the plots. But it's been 2 hours. It's been 2 interesting hours because I studied some of the problems I wanted to. Let's play some Counter-Strike 1.5 because we enjoyed the 2 hours, so we are not gonna my brain is not blocked now. So okay, 2.5, fuck that. I will say 1.5 and it doesn't work. I have to learn 2.5 and great. Raw. So yeah, then we are going to plot. It's kind of sad though. What's happening? so glad. Good kill. Good kill. Damn. How did they vote? What do I expect? They're waiting there for us. Where are you? What the? I killed. Oh my fucking. Where are you? Bro, I killed. This guy I killed. Who are you? Yeah, I'm playing so bad. Oh shit. Two at a time? Bruh. Oh, fuck you! Bitch. Is anybody here? Bro. No. Fuck! 3 times knifed. That was historic. Okay. Okay, dude. Bruh. I'm terrible at this game. This guy, who is this asshole? Alright, you knifed us. Okay. Better. Oh, I didn't even kill this guy. Oh my god. Oh, bitch. So you're here. What am I doing? Jump out. What are you doing? What happens in the pool, by the way? That's the that motherfucker is over there. I saw you, bitch. You're being arrogant. Oh. Bro, I knew he was there. Yeah, I'm not gonna risk it. Who? He's still here? No fucking way. Bro, stop. It's not fun anymore. This guy already killed me 4 times. Oh my god, this was a joke. The guy electrocuted me twice, knifed me twice. Man, was about to kill me for the 3rd time. He nailed. Wait a second. Who won? Ah, they were not even their best. This guy was just killing 23. Well, he was using knife all the time. Oh shit! Okay, guys, I have to leave because there is a fucking. Fuck you guys, you wanna kill me. I wanna watch final. What's happening? Alright guys, love you all. Take care of yourself. Watch Olympics. Do sport. Do sport. Don't watch sport unless you do sport.